Welcome, welcome, welcome. Welcome to the Jamb Master 30-day challenge. Chemistry day 1. Chemistry day 1. Chemistry day 1. The Jamb Master 30 days challenge. Chemistry day 1. Welcome back. Nothing can stop us today. Nothing can stop us today. Nothing can stop us today. The Jamb Master Chemistry challenge day 1. You are all welcome back. Please let me know if you can hear me now. Let me know if you can hear me now. Let me know if you can hear me now. Let me know if you can hear me now. Let me know if you can hear me now. Welcome back. Welcome back. Nothing will stop us today. Welcome back. Welcome back. Nothing will stop us today. Nothing will stop us today. Nothing will stop us today. Welcome back. Welcome back. Welcome back. Let me know if you are back. Say, I am back, sir. I am back, sir. Let me know if you are back. Say, I am back, sir. I am back, sir. I am back, sir. Let me know if you are back. Let me know if you are back. Can you hear me now? 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 Say I can hear you. Everybody just saying I'm back. Let me know. Please, can you hear me now? Say I can hear you, sir. If you can hear me. I want to go to the board now. I want you to let me know if you can hear me from the board. I want to go to the board. You know, I'm close to the phone, so you can hear me now. But I want to go to the board. I want to know if you can hear me from the board. If you can hear me from the board, say I can hear you from the board, sir. Is the board clear? The board is clear and you can hear me. If you can hear me from the board, say I can hear you from the board, sir. I can hear you from the board, sir. And the board is clear, right? So that we can start. There's no time to waste. You can hear me from the board. Let me see the comment and we'll start. Can you hear me from the board? Some people said not loud. Let me move my phone closer to the board. We don't need any excuse for today's class at all. I'll move my phone closer to the board so that it can be close to me. Yes, yes, yes. Some people say they can hear me. Some people say they can't hear me. Increase the volume of your phone, please. Increase the volume of your phone to the maximum, please. Don't be a negative person today, please. There's no time. Increase the volume of your phone. Increase the volume of your phone to the loudest. Put your phone on loudspeaker. Try everything possible from your hand. I'm shouting at the top of my voice here so you can hear me. I've brought the phone forward to the board now. Can you hear me from the board so that we can start? Can you hear me from the board so that we can start? Can you hear me clearly from the board so that we can start? Relative atomic mass. Can you hear me clearly from the board so we can start? Good. Everybody say yes, sir, very clearly. Everybody say yes. I like the energy. This is good. This is good. Yes. Everybody said yes. Everybody said yes. Well done. Let us start. Let us start. Let us start. Let us start. Please write down, as I said earlier, these are the 8 topics you must cover this night. There's no time to waste. Let us quickly start with relative atomic mass. Relative atomic mass. Right now, relative atomic mass. Let's define it, then we'll take questions. The relative atomic mass. Okay, please take note. There are 2 videos before this class. I sent the 2 videos to the group, right? There are 2 videos before this class. Because if I have to take chemistry from the beginning, this is not the first thing we should do. The first thing in chemistry from the beginning is your elements, compounds, and mixture. An introduction to chemistry. Elements, compound, and mixture, separation techniques, but I've taught it before. And throughout the day, I've been reposting that video to the group so that you can watch it before you come live. I've been reposting that video back to back. But no problem, if you don't still watch the video, I will repost it again on the group. There are 2 chapters, 2 videos I've done on chemistry before reaching this point. Now, so that we don't waste time, those videos are on my YouTube channel and they're also on our group. I will repost them again. Go and watch them in your spare time so that when you are coming here, I will now go flow together. So please take note. So relative atomic mass, write down. Is the average mass of an atom. Write down. The relative atomic mass is the average mass of an atom. Is the average mass of an atom. Relative atomic mass is the average mass of an atom. is the average mass of an atom of an element. Relative atomic mass is the average mass of an atom of an element compared with 1/12 of the mass of a carbon-12 atom. The relative atomic mass of an element is the average mass of an atom of an element compared with 1/12 of the mass of the what? Of a carbon-12 atom. Yes, very important. Relative atomic mass. Relative atomic mass. Now let's go to relative molecular mass. Relative molecular mass. Relative molecular mass is a sum. Relative molecular mass is the sum of the relative atomic masses of all the atoms present in the molecule. Relative molecular mass is the sum of the relative atomic masses of all the atoms present in a molecule. Relative molecular mass is the sum of all the what? Relative atomic masses of all atoms present in a molecule. Class, so relative atomic mass is basically for atoms, while relative molecular mass is for a whole molecule. Class, atoms come together to form molecules. For example, if you have H2O, this is a water molecule. In the water molecule, there are 2 atoms of hydrogen. You can see H2, so 2 hydrogen and 1 atom of oxygen. So to find the relative molecular mass of water molecule, you're going to add up the sum of the relative atomic masses of each atom that makes up the molecule. You're going to add up the relative atomic mass of each atom that makes up the water molecule. That's how you get relative molecular mass. But relative atomic mass, on the other hand, is the average mass of an atom. So for every specific atom, so relative atomic mass is specific for an atom. It is specific for an atom. For one atom, is the average mass of an atom of an element compared with 1/12 of the mass of a carbon-12. But relative molecular mass, class, as we said, relative molecular mass is the sum of the relative atomic masses. So you add up the relative atomic masses of all atoms present in a molecule. The sum of the relative atomic masses of all atoms present in a molecule give you the relative molecular mass. Let's take a very simple question like, if we ask to find the relative molecular mass of H2O molecule, find the relative molecular mass of H2O molecule. You will need to what? Add up the relative atomic mass of each atom present in H2O molecule. So class, in the exam they'll probably give you your H as 1 and your O as 16. One good thing I like about Jamb is that they usually give this H1, O16. Your job is now to say that since we have 2 hydrogen and 1 oxygen, H is 1, right? But we have 2 of hydrogen, so we're going to say 2 times 1 plus 1 oxygen. 1 oxygen is 16. So relative atomic mass of hydrogen is 1. For 1 atom of hydrogen is 1 gram. And for 1 atom of oxygen is 16 gram. So now say 2 times 1 is 2 plus 16, giving you 32 gram per mole. This is the relative molecular mass of H2O molecule. I hope we are still following. 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 Someone give me a feedback. Give me a feedback quickly so I can continue. I hope the class is still clear. You're still hearing me, right? Someone give me a feedback quickly. Give me a feedback. Please, give me a feedback. You can still hear me and the board is clear, right? Okay, good. Thank you. Good. That's what I want. Let's continue. Class, using this concept, let us also find the relative molecular mass for H2SO4. Let us find the relative molecular mass for H2SO4. Class, take note, any day we are fast and we finish the topics on time, and there's still time, we go into the next topic for the next day. The more topics we can cover, the better. Are we together? So now, let's look for the relative molecular mass for H2SO4. Please, nobody should say that I'm fast or they don't understand. Just rewind the video and watch again. If I'm too fast, rewind the video and watch again. You'll still catch up with us. This is an online class. Rewind the video and watch again. Let's look at relative molecular mass for H2SO4. Class, to find the relative molecular mass of H2SO4, you must first find, of course, they will give you this. H is 1, S is 32, and O is 16. To find the relative molecular mass of H2SO4, you're going to say, how many atoms of hydrogen do you have here? You have 2 hydrogens, you have 1 sulfur, and you have 4 oxygens. So the relative molecular mass of H2SO4 will be 2 times hydrogen is 1, plus 1 times sulfur is 32, plus 4 times oxygen is what? 16. 2 times 1 is 2, 1 times 32 is 32, and 4 times 16 is 64. So you're going to say 2 plus 32 is 34, 34 plus 64 is 98 gram per mole. This is the relative molecular mass of H2SO4. Class, this is the foundation of anything you'll be doing in chemistry. If you cannot find relative molecular mass of any molecule, then there's fire on the mountain. Then there's fire on the mountain. Quickly, then I'll give a quick class work. I'll give a quick class work. Right now, then I'll give a quick class work. Let me give you something more complex. We'll find the relative molecular mass for the following. We're going to find the relative molecular mass for the following quickly. AlOH3, 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 NH4, to SO4, NH4 to SO4. We want to find the relative molecular mass of NH4 to SO4 and AlO3. NH4 to SO4 and AlO3. I hope we are still together. I hope we are still together. I just saw a comment now. Class, did I make a mistake in H2O? H is 1 times 2 plus 16. 1 times 2 is 2. 2 plus 16 is 18 gram per mole. 18. Did I say 32? That must be a very funny mistake. Did I say 32 here, class? Very funny mistake. Place is 18. 18. Everybody knows that water is 18. Thank you for your comment. Without your comment, I wouldn't have known. If not for your comment, I wouldn't have known. So it's good I also check comments. Class is actually 18, not 32. How did I say 18? How did I say 32? Thank you for your comment. Yes. Water is 1 times 2 is 2. 2 plus 16 is what? 18 gram per mole. Coming to this, H2, 2H, 1S, 4O. The oxygen is 4. We have O4, so oxygen is occurring 4 times. 1 sulfur atom and 2 hydrogen atoms. Since hydrogen is 1, we say 2 times 1, 2. 1 sulfur is 32, so 1 times 32. And oxygen is 16, 4 times 16. 2 times 1 is 2, 1 times 32 is 32, 4 times 16 is 64. We do the math and we have 98 gram per mole. Class, water is 18 gram per mole. Everybody knows that. Now, class, quickly, let's look at this two before we move from relative molecular mass. We have AlOH3. And we have to find the what? Relative molecular mass. Class, obviously, they will give us the relative atomic mass for aluminium. The relative atomic mass for aluminium is what? 27 gram. Relative atomic mass for oxygen is 16 and hydrogen is 1. So we are going to say aluminium is 27 plus oxygen is 16. But we don't just have oxygen here, we also have what? Hydrogen. What's hydrogen? Hydrogen is 1. But everything multiplied by what? By 3. Everything multiplied by 3. So we're going to say 27 Plus 16 plus 1, you have 17. 17 times 3. 17 times 3, I think, should be 51. So then we're now going to say 27 plus 51, and we're going to have 78 gram per mole. 78 gram per mole. This is the relative molecular mass of AlOH3. Now, NH42SO4. NH42SO4, take N as 14, take H as 1, take S as 32, take O as 16. So you're going to say N is 14 plus H is occurring 4 times. So we're going to say 4 times, what's H? H is 1, so 4 times 1, 4. But everything multiplied by 2 because NH42, everything multiplied by what? 2. Plus sulfur is 32. Oxygen is 16 multiplied by 4. The oxygen is occurring 4 times. 14 plus 1 times 4 is 4. Everything multiplied by 2 plus 32 plus 16 times 4 is 60. 14 plus 4 should give us 18. 18 times 2 should give us 36. Plus 32 plus 64. 36 plus 32 should give us 68. 68 plus 64. 68 plus 64 should give us 132 gram per mole. Someone should confirm that with the calculator. 132 gram per mole. 132 gram per mole. 132. Who got the 2? You got the 2 before I got it. Let me know in the comments. Sir, I got it before you got it. 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 I got it before you got it. Yes. Sir, I got it before you got it. Sir, I got it before you got it. Sir, I got it before you got it. Some people are asking for the atomic mass of aluminium. But in my first 2 videos, I have already taught our students how to get the atomic mass of elements. Even if you are not given. Our first 2 videos, if you notice some students are not asking for mass because I've taught them how to get it. If you missed the first 2 videos, I will send it on the group after this class. Don't worry yourself. Let's continue. So class, congratulations. We have successfully cleaned off relative atomic mass and relative molecular mass. We have cleaned off what? Relative atomic mass and relative what? Molecular mass. We have cleaned off relative atomic mass and relative molecular mass. Let us now go to mole concept. Mole concept. Let us go to mole concept. Please, in case I'm too fast, rewind the video. I've said it several times. I don't want to see anybody complaining on the comment section. Just rewind the video and watch again. You have the power. Online class gives the students the power. Just rewind the video and watch again. Enjoy yourself. Are we together? You can watch this class like 10 times. That's the advantage of an online class. This class, you can watch it 10 times. Right, let's go to mole concepts. Mole concepts. A mole. Let's define what is a mole. A mole is the amount of substance. A mole is the amount of substance that contains Avogadro's number of particles. The amount of substance that contains Avogadro's number of particles. Class, a mole is the amount of substance that contains Avogadro's number of particles. What is Avogadro's number of particles? We'll call it N. 6.02 times 10 raised to power 23 particles. So class, what I'm doing now is mole concept and Avogadro's number together. Class, you cannot mention mole concept without talking about Avogadro. And you cannot talk about Avogadro without talking about mole concepts. 2 of them go hand in hand. Mole concept and Avogadro's number go hand in hand. Yes. So Avogadro's number of what? Particles is 6.02 times 10 raised to 23 particles. Class, in chemistry rules, we know that 1 mole of any substance is equivalent to 6.02 times 10 raised to power 23 particles or molecules or atoms. 1 mole of any substance, class, no matter the substance, whether it's an element, whether it's a compound, whatever substance, 1 mole of any substance contains 6.02 times 10 raised to power 23 particles, molecules, or atoms. Yes, 1 mole of any substance, 1 mole of any substance is equivalent to 6.02 times 10 raised to power 23 particles, or molecules, or atoms. Yes, 1 mole of any substance is equivalent to 6.02 times 10 raised to power 23 particles, or molecules, or atoms. 1 mole of any substance is equivalent to 6.02 times 10 raised to power 23 particles, or molecules, or atoms. Please take notes. Class, another formula you must note is that the number of mole of any substance is the mass of the substance divided by the what? Molar mass. Class, the mass of any substance divided by the molar mass. The mass of any substance divided by the molar mass is the number of moles. Number of moles is mass divided by the molar mass. Mass of substance divided by the molar mass. Please take note. 1 mole of any substance contains 6.02 times 10 raised to 23 particles, molecules, or atoms. Please remember that this video will be available for you. If you are lost now, after you have watched this night's class, I will still advise you. Tomorrow morning when you woken up with a fresh brain, click that link I sent you on the group. It will take you to this video again. Scan down and watch it again. By the time you watch it 2-3 times, you'll get it. So don't worry yourself. Are we together? So instead of complaining or murmuring, what you just do is that, sir, I'm lost. Okay, I'll go and click on the link tomorrow morning. I will stay for the class and watch to the end. Tomorrow morning, I will click on that link they sent on the group. You don't need to ask me for any link. Just click that same link they sent on the group. It will bring you back to the video. Calm down, watch again. Are we together? You can watch 10 times till you understand, so there's no problem. It's only an unwise person that will say they don't understand an online class. Why? Because online class, as long as the person gives you the link, you can keep watching again and again and again till you get it. Are we together? Now let's keep going. So we said number of moles of any substance is the mass divided by the molar mass. Let's take our first question. Find the number of moles of 44 grams of CO2. Find the number of moles of 44 grams of CO2. Find the number of moles of 44 grams of CO2. Find the number of moles of 44 grams of CO2. Don't forget the number of moles is mass all over molar mass. Find the number of moles of 44 grams of CO2. Class, when we say molar mass, it's similar to what we just discussed earlier, relative molecular mass. The relative molecular mass, mole is the molar mass. That means, what's the relative molecular mass? It's the molar mass. Number of moles is mass all over molar mass. We're asked to find number of moles of 44 grams of CO2. Class, this 44 grams they gave us is the mass. Class, when solving number of moles, we have the small mass M and the big mass M. Class, we use the small m to represent the small mass, the given mass, and the big M to represent the molar mass or relative molecular mass. So this can stand for molar mass or relative molecular mass. RMM means relative molecular mass. We use small m to represent the given mass. We use big M to represent the molar mass or relative molecular mass. Class, on this question, they say we should find the number of moles of 44 grams of CO2. Take C as 12. Take O as 16. So you're going to say, what's the mass of CO2? 44 grams. What's the molar mass of CO2? 12. Plus O is 16. 16 times 2, 30. Because oxygen is occurring twice. O is occurring what? 2. So 16 times 2, 32. 12 plus 32, 44 grams per mole. Class, you can see that the mass and the molar mass in this question are the same. So you say 44 divided by 44, you're going to have 1 mole. So the number of moles in 44 grams of CO2 is 1 mole. Now let's take another question. How many moles are present in 9 grams of H2O? How many moles are present in 9 grams of H2O? How many moles are present in 9 grams of H2O? I want to do that quickly. Take H as 1 and O as 16. Do that quickly, do that quickly. Let's see what you have. Take H as 1 and O as what? 16. How many moles are present in 9 grams of H2O? Let's see what you have, class. Let us see what you have. Let us see what you have. Let us see what you have. How many moles are present in 9 grams of H2O? How many moles are present in 9 grams of H2O? First answer. First answer. First answer. How many moles are present in 9 grams of H2O? First answer. First answer. First answer. Class. Number of moles is mass over molar mass. Mass is 9 grams. What's molar mass? H2O. We have done H2O before. We got 18. Remember? We got 18. 9 divided by 18, you have 0.5 mole. 9 divided by 18, you have 0.5 mole. Yes. So class, this is how you can be questioned on number of moles. But that's not all. This is how you can be questioned on number of mole. This is how you can be questioned on number of mole. Class, but there's another way you can be questioned on number of mole I must teach you. Class, if they don't ask you to find number of mole using mass or molar mass, they can ask you to find number of mole using Avogadro's number. You could be asked to find number of mole using Avogadro's number. Let us look for a question that asks us to find number of moles using Avogadro's number. Let's look for a question that asks us to find number of moles using Avogadro's number. Yes. Take this question down. Find the number of atoms and number of moles. You are looking for two things. Find the number of atoms and the number of moles in 2 times 10 raised to power minus 2 grams of carbon. Find the number of atoms and the number of moles in 2 times 10 raised to power minus 2 grams of carbon. Find the number of atoms and number of moles in 2 times 10 raised to power minus 2 grams of carbon. Find the number of atoms and the number of moles in 2 times 10 raised to power minus 2 grams of carbon. Class, when they ask to find the number of atoms and find the number of moles, these are 2 different questions. Class, don't forget, the Avogadro's number is 6.02 times 10 raised to power 23 atoms. What this tells us is that for every mole of carbon, because 1 mole of any substance is equivalent to 6.02 times 10 raised to power 23. 1 mole of any substance is equivalent to 6.02 times 10 raised to power 23 atoms. But we have to find how many atoms are in 2 times 10 raised to minus 2 grams of carbon. Claude, there's something you must also know. Apart from 1 mole being equivalent to this, don't forget that 1 mole of any substance is also equivalent to the relative molecular mass of that substance. Class, 1 mole of any substance is also equivalent to relative molecular mass of that substance. If 1 mole is equivalent to 6.02 times 10 raised to 23 atoms, and 1 mole is also equal to the relative molecular mass of that substance, it implies that the relative molecular mass of any substance is also equal to 6.02 times 10 raised to 23 atoms. If 1 mole of any substance is equivalent to the relative molecular mass of a substance, it means that the relative molecular mass of any substance is equal to 6.02 times 10 raised to 23 atoms of that substance. Class, what is the relative molecular mass or atomic mass of carbon? Carbon is 12. The atomic mass of carbon is 12 grams per mole. What this means is that 12 grams can be equivalent to 6.02 times 10 raised to 23 atoms. So if 12 grams equals to 6.02 times 10 raised to 23 atoms, we are now asked to find the number of atoms in 2 times 10 raised to minus 2 grams of carbon. If 12 grams is 6.02 times 10 raised to 23 atoms, what of 2.0 times 10 raised to minus 2 grams? How many atoms will be found here? We don't know. Call it X. We don't know, so we'll call it X. Class, I'll come again for this one. I said 1 mole of any substance. Let's start from here. 1 mole of any substance, according to Avogadro's number, is equivalent to 6.02 times 10 raised to 23 atoms. But 1 mole of any substance is also equal to relative molecular mass or relative atomic mass. Relative molecular mass or relative atomic mass. We use relative molecular mass when dealing with molecules. We use relative atomic mass when dealing with atoms. For example, we are dealing with an atom of carbon here. We are dealing with an atom of carbon here, so relative atomic mass. Thank God we just defined what is relative atomic mass. We just do relative atomic mass, and we've also done relative molecular mass. So I'm saying that 1 mole of any substance is equivalent to the relative molecular mass of that substance, or the relative atomic mass of that substance. What does that mean? It means that the relative atomic mass of carbon, for class, the right term to use is relative atomic mass. When dealing with an atom, we call it relative atomic mass. When dealing with a molecule, we call it relative molecular mass. Please take notes. When dealing with an atom, we call it relative atomic mass. When dealing with a molecule, we call it relative molecular mass. So relative atomic mass of carbon, we are dealing with an atom of carbon. I think this question was CO2. We're not going to use relative atomic mass, we use relative molecular mass. But CO2 is a molecule. The difference between carbon and CO2 is that carbon is just an atom, CO2 is a what? Molecule. What's the difference between atoms and molecule? A molecule consists of combination of atoms. Combination of atoms makes up a what? A molecule. But this is just an atom, carbon, standing on its own. So when dealing with atoms, you use RAM, relative atomic mass. When dealing with molecules, CO2, use relative molecular mass. Please take notes. So my point is that 1 mole of any substance is equal to relative molecular mass of that substance, or relative atomic mass of that substance. And so the relative atomic mass of any substance is also equivalent to 6.02 times 10 raised to 23 atoms. What's the relative atomic mass of carbon? 12. So 12 grams of carbon equals to 6.02 times 10 raised to 23 atoms of carbon. But the question we have here is 2 times 10 raised to minus 2 grams. How many atoms will it contain? We'll call it X. So we'll cross multiply. 12 times X is 12X. Should be equivalent to 2.0 times 10 raised to minus 2 multiplied by 6.02 times 10 raised to 23. Who has already gotten the answer while I'm solving? Type in the comment section. Got to tell me your answer. Not after I finish solving, you not type what I got. Tell me your answer and let me know. You've gotten it. Let me see my best chemistry student in this set. Let me see my best chemistry student in this set. But please, if you've not gotten it, you are slow in chemistry. Don't worry yourself. You've met the right person. Concentrate. Everybody knows their level. Just concentrate. Don't be moved. Don't be distracted by anybody. Just learn. You are here to learn. And I'm here to help you understand chemistry. Now let us make X solid on the formula. Divide both sides by 12. Divide both sides by 12. So that 12 cancels 12. And we're going to have 2.0 times 6.02. 10 raised to minus 2 times 10 raised to times 10 raised to 23 will give you 10 raised to 21. Because 23 minus 2 is 21. 23 minus 2 is 21. All over 12. Class 2 times 6.02 is almost is 12. It should be 12.0 something, maybe 12.04 times 10 raised to power 21 divided by 12. Class, this is basically 12 divided by 12 because this 0.04 is negligible. So 12 divided by 12 obviously is 1. So let's call this 1.0 times 10 raised to power 21 atoms. So class, 12 point, so the answer is 1.0 times 10 raised to power 21 atoms. So the question says find the number of atoms in 2 times 10 raised to minus 2 grams of carbon. This is the number of atoms. Who got this? Let me know in the comment section. And let me also check if you can still hear me and if you can see the board. Good, good. 1.0 times 10 raised to power 21 atoms. Good, good. Well done, class. Well done, class. Well done, class. Well done, class. 1.0 times 10 raised to power 21 atoms. You can still see the board, right? And you can still hear me, right? You can still see the board and you can still hear me, right? You can still see the board and you can still hear me, right? Good. Someone said I was wrong. Good. Correct yourself. Correct yourself. Correct yourself and let's move forward. Correct yourself and let's move forward. Correct yourself and let us move forward. Quickly, quickly, quickly. No time to waste. We have more questions for you. Please, I told you I'll be fast. So, if you've not gotten it, rewind the video or pause the video and copy again. We can't wait for you. This is an exam marathon class. This is an exam marathon class. We can't wait for you. We can't wait for you. We can't wait for you. Pause the video, rewind. I don't want to see you behaving like a village person. No. Don't start saying, sir, please don't play the board. You're not in physical class. This is an online class. Rewind the video and you can see it again. So I don't want to see anybody complaining, sir, why are you cleaning? I don't want to see anybody saying, I don't understand. This is an online class. Don't behave like a village person. This is an online class. You can rewind the video and watch again. So if you are saying you don't understand, it's just showing that you are not exposed. You're in an online class where you can rewind the video and watch again. You are saying you don't understand. When the power is in your hand, rewind the video and watch again. Don't disgrace your village people. Let's go. How many moles of limestone? Okay, let's not take that yet. We're not ready for that yet. But that was when we deal with reactions. Let's take this one. Let us take this one. Let us take this one. If 1 mole of aluminium contains, if 1 mole of aluminium contains 6 times 10 raised to power 23 atoms of aluminium. How many atoms are contained in 0.9 gram of aluminium? How many atoms are contained in 0.9 gram of aluminium? If 1 mole of aluminium contains 6 times 10 raised to power 23 atoms of aluminium, how many atoms are contained in 0.9 gram of aluminium? Did you get the question? 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 I hope you got the question. Okay, solve. Let us see what you have. Let us see what you have. Solve. Let us see what you have. I'm giving you 1 minute to solve. I'm giving you 1 minute to solve. I'm giving you 1 minute to solve. Who is done? 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 Someone said 2.01 times 10 raised to power 22. Okay. Someone said 2.01. No time to waste. Let us go, class. The atomic mass of aluminium is 27 gram per mole. So, class, but 1 mole of aluminium is equal to 27 gram of aluminium and is equal to 6.02 times 10 raised to power 23 atoms. 1 mole of aluminium is equivalent to 27 gram of aluminium and contains 6.02 times 10 raised to power 23 atoms of aluminium. But now I want to find the number of atoms in 0.9 gram of aluminium. If 27 gram of aluminium contains 6.02 times 10 raised to power 23 atoms of aluminium, 0.9 gram of aluminium will contain how many atoms? Call it X. If 27 gram of aluminium contains 6.02 times 10 raised to power 23 atoms, 0.9 gram will contain how many atoms? Call it X, we don't know. Can then cross multiply. So you have 27 times X is 27X equal to 0.9 times 6.02 times 10 raised to power 23. What will this cross multiply? Now divide both sides by 27. 27 cancels 27, and then you do your math here. Let me get my calculator so I can do my math as you are doing yours. Let me get my calculator so I can do my math as you are doing yours. Yes, my calculator is here. So we have 0.9 multiplied by 6.02 equals 5.418. So we have 5.418 times 10 raised to power 23 divided by 27. So 5.418 divided by 27. You're going to have 0.2 times 10 raised to power 23. But if you bring this decimal point 1 to make it standard form, you're going to have our final answer will be 2.0 times 10 raised to power 22 atoms. 2.0 times 10 raised to power 22 atoms. That's what you're going to have. That's what you're going to have. Who got this? Who got this? Who got this? That's what you should have there. That's what you should have there. That's what you should have there. Let's take one more question. Let's take one more question quickly. Remember, I don't want to hear you say, sir, you are too fast. I don't clean, I'm still writing. I'm not in physical class. Pause the video, rewind it, and catch up. Everything that is here now, the phone has recorded it already, it's captured already. Just rewind and watch again. And don't forget, tomorrow you can still sit down and watch everything again. If you don't want to be rewinding too much, just flow the class to the end. Then tomorrow, come back and watch again with a calm mind. That time you're not rushing, I'm not rushing, you'll just be the only one watching it. I was going to finish the class first, so don't make sure you don't leave the class. Don't leave the class. In fact, we did not make our commitment. Our usual commitment in our life class that I will not leave till the end. Someone should type it because it's not too late. It's never too late. Type, I will not leave till the end, till I finish these topics. I will not leave till the end. Type on the comment section. We used to make our commitment in all our classes. We make a commitment before we start. I will not leave till the end. Type in the comment section. I will not leave till the end. Type in the comment section. I will not leave till the end. 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 How many moles are there? How many moles are there in 40 grams of Na2CO3? How many moles are there in 40 grams of Na2CO3? Take Na as 23. Take C as 12, take O as 16. How many moles are there in 40 grams of Na2CO3? Yes, I like the energy. Everybody's saying it. I will not live to the end. Everybody's saying it. Everybody's saying it. This is the commitment. I like this set. Everybody's saying it. I will not live till the end. I will not live till the end. Everybody's saying it. I will not live till the end. Everybody's saying it. I will not live till the end. Well done, class. Divine King Justice, I see you. Yes. Medover Boy, I see you. Edafe Wisdom, I see you. Well done. If you cook for Stina, I see you. Yes. Everybody's saying it. I will not. Udochukwu Kindness. Well done. Temilade Jadesola. Alex Victory said, I will not live till the end. Ken Dave Fetia said, I will not live till the end. Blessing Chidima, Favor Pious. Everybody's saying it. Good luck, Ambunike, prayer culture. I will not live till the end. I'm saying you. Raphael Ajibade. Yes, I will not live till Abiola. I'm saying you. I will not. Abiola Banjo said, I will not live till the end. Well done, class. Well done, class. How many moles are there in 40 grams of Na2CO3? Class, this question is number of moles equals to mass all over molar mass or relative RMM. The mass given is 40 grams. The molar mass of Na2CO3 is what we have to find. Na2CO3 means 2 sodiums plus 1 carbon plus 3 oxygens. What's the value of 2 sodium? 1 sodium is 23. So 2 times 23. 1 carbon is 12 plus 1 times 12. 3 oxygen. Oxygen is what? 3 times 16. 2 times 23 is 46. 1 times 12 is 12. 3 times 16 is 48. 46 plus 12 plus 48. Who can tell us that what that is? I think that should be 106. 46 plus 12 plus 48. 46 plus 12 plus 48. 106 gram per mole. So we've gotten the big M. The big M for this guy is 106. The small m is 40. So 40 is small m. Big M is 10. So say 40 divided by 106. 40 divided by 106. That will give us 0.37735 moles. Now your option will determine how many decimal places you leave it. If we are taking only this first two, then we'll round this up to approximately 0.38 moles. Because this 7 will cause an addition of 1 here, right? 7 will cause an addition of 1 here. So 0.38 moles. Approximation. You did it in secondary school, right? Yes. Class, congratulations. We have successfully wrapped up mole concept and Avogadro's number. So one good thing about this plan is that we are doing chemistry throughout this week. Someone was saying, I hope we'll be able to cover. I saw someone posting on the group. I hope sure we'll cover this thing. It's only chemistry we are doing. Don't you get the plan? We're not going to any other subject. So throughout this week is chemistry. So how will we not cover? We're not leaving chemistry till we finish it. And we've already divided all the topics, all the key topics in chemistry. Why did I notice the topics I chose? I chose this topic based on the 80-20 principle. Jamb sets 80% of their questions from 20% of the Jamb syllabus. Any topic I teach here, they are core Jamb topics. Core Jamb topics. And it is almost 80% of the Jamb syllabus that I brought out. In that Jamb syllabus, if you look at that list I gave you, those that joined very late, you might not have seen the list. I sent them a list, topic by topic. Everything will be touching every day. After this live, I will send again. The topics will be touching everything. So day one is remaining just 4 topics. Day one remaining just 4 topics. Every day our target is finish this 4 topics. We have a target, so it's easy to cover. Now when you come into a class, knowing what you have to do is easier to cover. So we're going to cover. We're going to do what? Cover. Let's go to percentage composition. Let us go to percentage composition. Every day from now till Sunday, this class ends Sunday. Chemistry ends on Sunday. Then Monday next week we start physics like this. In 4 weeks we are finishing your Jamb syllabus. It's clear, very clear. And you are lucky. Science students, they are very lucky. Let me tell you why. Your own is live on the board. Art and commercial students, they are not watching live. Although art is watching live too. Art is actually watching live. Government is holding now. The teacher is teaching. She recorded the class and will send them the videos for art. But commercial is not on YouTube. It's not live. They are just doing it on in the WhatsApp group. But science, you are very lucky. I'm the one personally taking you. Do you understand? So I will cover my syllabus definitely. Now, so every day this week is chemistry only. We are bombarding ourselves with chemistry. Percentage composition. Write down percentage composition. Percentage composition. This is the percentage by mass of each element present in a compound. Percentage composition. This is the percentage by mass of each element present in a compound. This is the percentage by mass of each element present in a compound. The formula for percentage composition is mass of elements divided by the what? Total mass of the compound or molecule. Mass of element divided by total mass of the compound. Mass of element divided by total mass of compound. Mass of element divided by total mass of the compound. Mass of element divided by the total mass of the compound. Mass of element divided by total mass of the compound. Can you still hear me? Please type I can hear you if you can still hear me. Type I can hear you, sir, if you can still hear me. Type I can hear you, sir, if you can still hear me. Mass of element divided by total mass of the compound. Percentage composition. Percentage composition. Mass of element divided by total mass of the compound. Class, let us take question. Class, I don't want to give you a simple question for this. I want to give you a tough question. Let us not do simple question for this. Calculate the percentage composition of the following components. In CuSO4.5H2O. In CuSO4.5H2O. 1. Oxygen. 2. Water of crystallization. How many of you remember in those first 2 videos we did, I taught you 4 types of substances in chemistry, right? I taught you the liquescent substance, I taught you hygroscopic substance, I taught you a fluorescent substance, and I taught you a effervescent substance. In those first 2 videos we did earlier, I taught you that, right? If you've not seen the videos, I will send the link after the class. Don't worry yourself. CuSO4.582 is an efflorescent substance. What is an efflorescent substance? An efflorescent substance is a substance that releases water of crystallization. When exposed to the atmosphere, it loses water of crystallization. Are you aware that CuSO4.582 contains 5 moles of water of crystallization? This is the water of crystallization. So now in this question, they ask us to calculate the percentage composition of the following components in CuSO4.582. 1, oxygen. 2, the water of crystallization. Now what is the percentage of the water of crystallization in the molecule? What is the percentage of the water of crystallization in the molecule? So find the one for oxygen and find for water of crystallization. Class, don't forget, that percentage composition is mass all over what? Molar mass times 100%. Mass of elements or components divided by the molar mass times 100%. Let us start with oxygen. Class, you're going to ask yourself, what's the total mass of oxygen inside this compound? How many oxygen do you have inside this compound? We need to find the mass of oxygen inside the compound. How many oxygen do we have here? We have 4 oxygens on this side. And class, this 5 also affects everybody here. So this 5 is for oxygen. So we have 5 oxygens from water and 4 oxygens from CuSO4. Means that we have a total of 9 atoms of oxygen. We have a total of 9 because 4 plus this 5 oxygen. 5 is also for oxygen. 5 oxygens, 4 oxygen. 5 plus 4 is 9. So we have 9 oxygen. And 1 oxygen is what? 16. Let me give you everything. Copper is 64. This is copper. Cu is 64. Take S as 32. Obviously H is 1. Yes. So this will now be 9 multiplied by 16. 9 multiplied by 16. 9 multiplied by 16 should give us 144. Someone should confirm that, but I think it's 144. 144. So if the mass of oxygen in this compound is 144 grams, we now also have to find total mass of the whole compound, CuSO4.582. The total mass of CuSO4.582. Who is Cu? Cu is 64. Plus who is S? S is 32. You can see S is 32. O, we have established that we have 9 oxygens here. The 9 oxygens is 144. Because we have 4 oxygens here and we have 5 oxygens here. 9 oxygens, 9 times 16, 144. Each remaining hydrogen we have not dealt with. How many hydrogens do we have here? Class, hydrogen is 5 and 2. 5 times 2 is 10. 10 hydrogens means 10 times 1. Because for each, every hydrogen is 1. So 10 times 1, 10. So you have 64 plus 32 plus 144 plus 10. This looks like 250. Someone should confirm. I'm naturally good in maths, but still confirm the calculator. This looks like 250. Someone should confirm it. Confirm it. Let me confirm as well. Let me confirm my calculator. Let me confirm my calculator. 64 plus 32 plus 144 plus 10. Yes, 250. So total mass of the full compound is 250. Mass of all the oxygen in the compound is 144. Let us now find the percentage composition. Percentage is the mass of the element divided by the total mass. That is 144 divided by 250 times 100%. 144 divided by 250 is 0.576. Then multiply by 100%. We give us 57.6%. So class, the percentage of oxygen in this compound is 57.6%. Let me come and check on the screen what is happening. I don't like to teach for long without knowing what is happening. It may be the network is bad, I will not know. So what is going on? Let me know in the comment section. Type your comment. Are you still hearing me? Are you still seeing? Are you still hearing me? Are you still seeing? Can you still hear? Can you still see? Can you still hear me? Can you still see? Can you still hear me? Can you still see? Can you still hear me? Can you still see? Excellent. Good. You can hear me. You can see me. You can hear me. You can see me. Let's keep going. Let us keep going. Let us keep going. Let us keep going. Let us keep going. I'm about to clean the board now. And remember I said, don't expose your village people, because don't say, sir, why are you cleaning now? Some of you are still used to physical class. We need to remove that physical class from your system. We need to remove it from your system. You are used to a physical class. If a teacher will clean the board and you think you have lost everything. No, this is an online class. Just rewind the video and you see it again. So I'm about to clean the board now. For class, don't forget that total mass of CS4 is 250. So we'll now have to do it again. We now need to find the percentage of water. We need to find the percentage of water of crystallization. Class, we need to find the mass of water first. Class, we have done water before. The mass of 1 mole of water is 18. Do you remember? 1 mole of water is 18. Is equal to what? 18 grams. So 5 moles. For this water, how many water do we have here? We have 5 water. So 5 H2O must be 5 times 18. And that must give us 90 grams. So the mass of water is 90 grams. And total mass of CuSO4 is still 250, remember? CuSO4.5H2O is still what? 250 grams. So we are going to say 90 grams divided by 250 grams times 100% all over 1. Gram cancel gram. Let's visit our calculator again. 90 grams divided by 250 grams times 100% all over 1. 90 grams divided by 250 is 0.36. Multiplied by 100% will give you what? 36%. So therefore, class, the percentage of water in this compound is 36%. Who got this before I got it? Sir, I got it before you got it. Sir, I got it before you got it. Sir, you see how we're cleaning? You see how we're covering your syllabus? Are you seeing how we are covering your syllabus? Are you seeing? From 8 topics, we have 3 topics and you go and sleep this night. From 8 topics, we have 3 topics and you go and sleep this night. This is smart work. This is smart work. This is not hard work. This is smart organization. In 4 weeks' time, we cover your complete Jamb syllabus. Are we together? In 4 weeks' time, you see students say, I don't like tutorials, I like reading on my own. If you are reading on your own, you might not have come up with this kind of idea. But in this kind of challenge where you are meeting your fellow colleagues, you are challenging each other, iron sharpens iron. You say we are pushing each other and an expert comes to teach you and helps you with a plan to cover your syllabus. This is not the first time we are doing this. So you should know that I know what I'm doing. Because someone commented on the group, says, sir, hey, are you sure we can cover all these things? I was just laughing. I said, this person I just started teaching Jamb this year. I did not just start teaching Jamb this year. I know the Jamb syllabus very well. So I divided it into 7 days. There are topics for every day I will cover, and you see it for yourself. So we know what we are doing. Clean, write down so we can go to the next topic. Write down so we can go to the next topic. Oh, okay, remember it's an online class, so I can clean the board. You can rewind and watch again. It's an online class, I can clean the board. You can rewind and watch again. Yes. Let us go to empirical formula. 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 Empirical formula is the simplest whole number ratio. Empirical formula is the simplest whole number ratio of atoms in a compound. empirical formula is the simplest whole number ratio of atoms in a compound. And I want to give you 4 steps. Steps to solve empirical formula. Steps. Very simple steps to solve empirical formula. Let's call it EF. Let us call it EF. Empirical formula is EF. 4 steps. The steps to solve empirical formula. Class, it is not a mistake that we first did percentage composition before we did empirical formula. It's not a mistake that we first did percentage before we did empirical formula. Class, step 1 is to recognize the percentage composition. Recognize, or let's say identify. Identify the percentage composition of each atom in the compound. Identify the percentage composition of each atom in the compound. Step 1. Step 2. Now divide by their respective atomic masses. Divide by their respective atomic masses. Divide. By their respective atomic masses. Step 3. Divide by the smallest value till you have a whole number. Divide by the smallest value till a whole number is obtained. And the last step, write down the ratio obtained. Write down the ratio obtained. I hope we are still there. Write down the ratio obtained. We are quietly covering your Jamb syllabus. No noise, no much talks. Straight to the point, as you can see. We are quietly covering your Jamb syllabus. No time to waste. We are quietly covering your Jamb syllabus. Someone said, I hope the Jamb will be this easy. Because the past session scares me, chemistry in particular. Class, those parts that scare you, we are getting to them. Every topic that scare you, we are getting to them. This part is easy because if you went to a good secondary school, this day 1 topics are easy because they must have taught you well. Where chemistry starts becoming difficult is not in these topics. Where chemistry starts becoming difficult is organic chemistry. Are we together? Organic chemistry. Where it starts becoming difficult is where you call it stoichiometry, balancing of chemical equation, tomorrow's topic. All those concentrations, solubility, electrolysis, acid, base, and salt. Your normal salt, your double salt, your complex salt, you know, balancing of ionic equations, yes. Where chemistry starts becoming difficult, all those redox reactions, Le Chatelier's principle, yeah, that's where chemistry starts becoming tough. Are we together? So all those topics have been documented in our schedule. We have a day for each of those topics. So don't worry yourself. These are the simple topics. The beginning is usually very simple, yes. The beginning of chemistry is usually very simple. But surprised to know that some people don't still know this. Notice this classwork we're giving. Some people still missed it as simple as it was. Some people still missed it in the comments, right? So it's not our job to select the one that is simple and the one that is not simple. Our job is to teach you everything. Are we together? So we're taking it from the beginning. I can say empirical molecular formula, everything. I don't want to assume you know anything. I don't want to assume that you know anything. If I do that, I will not be doing you a favor. Imagine that I know a topic that I'll say you know that topic. I will not teach it. Then maybe you don't know that topic. You will not know they don't know it. So I will teach every. So don't worry yourself. Yes. Let us apply the empirical formula rule. Let us apply. Let us apply. Let us apply. Take this question down. A compound contains 40% carbon. A compound contains 40% carbon and 6.7% hydrogen. Find the empirical formula. A compound contains 40% carbon and 6.7% hydrogen. Find the empirical formula. A compound contains 40% carbon and 6.7% hydrogen. Well done, class. Nobody has left. Nobody has left. You can still hear me and you can still see the board, right? You can still hear me, you can see the board, right? A compound contains 40% carbon and 6.7% hydrogen. Find the empirical formula. Class. First things first. I intentionally chose this question because I know that most students will fall for a trap here. I know I'm giving you 4 steps to solve empirical formula, but class, there is one vital thing that is not mentioned in the steps that you should know. Class, when solving empirical formula, before you start solving, ensure to add up the percentages of the atoms that make up the compound. Is it up to 100%? If it is not up to 100%, something is wrong somewhere. An atom has been omitted. If you don't find that atom, anything you solve will be wrong. Now, a very naive student now will go ahead and start solving. It's not an empirical formula, I know it. You will say carbon. I know they taught you in secondary school. Carbon is 46%. Hydrogen is 6.7%. I know you know what to do. You now divide by, carbon is 12 gram, right? Carbon is 12. Hydrogen is 1 gram. The atomic mass of carbon is 12. Hydrogen is 1 gram. You now say 40 divided by 12. Hydrogen is 1. Hydrogen 6.7 divided by 1, right? You keep dividing to get the smallest one, right? That's what you were taught in secondary school, right? But class, there's something you are missing. When you add 40 to 6.7, you don't have 100%. Meaning that you have not been given a total composition of the compound you are dealing with. And if you solve like this, you're going to have a wrong answer. Class, I must inform you that they give you a percentage composition of atoms, especially organic carbon hydrogen, and it's not up to 100%. Class, for sure, someone is missing. And the person that is most likely omitted is oxygen. Class, it's a common thing they do. Class, let us add 40 plus 6.7. You're going to have 46.7%. Class, the compound is not up to its full capacity. It's not up to 100%. So who is missing? Oxygen. Please take note. Your job is to say 100% minus 46.7%. Let us do the math. You are going to have 53.3%. Class, this oxygen 53.3% was omitted. Imagine almost over half of the whole compound was omitted. 53.3% means over 50% was omitted. And you want to solve with these two, you'll be wrong. I haven't gotten the 3 components of the compound now we can now solve. Carbon is 12 gram, hydrogen is 1 gram, oxygen is 16. Now I'm giving you the atomic masses. You know you need the atomic masses. So 40% divided by 12, 6.7 divided by 1, and 53.3 divided by 16. Because oxygen is 16, hydrogen is 1, carbon is 12. You then start dividing. You start dividing. 40 divided by 12 should give you 3.33. 6.7 divided by 1 is 6.7. 53.3 divided by 16 is 3.3. Don't forget the next step. Start dividing by the smallest. Who is the smallest? 3.3, right? Divide this by 3.33. Divide everybody by 3.33. 3.33 divided by 3.33 will give us 1. 6.7 divided by 3.33 will give us 2. Approximately 2. And 3.3 divided by 1 will give us 1. So that the empirical formula is C1, C what? 1, H2O1. Same thing as CH2O. You don't need to mention 1 and 1 here, CH2O. Who got this before I got it? Sir, I got it before you got it. Sir, I got it before you got it. Let me see. Excellent. Someone already put CH2O there. Excellent. CH2O. Someone just wrote CH2. It should be CH2O. It should be CH2O. It should be CH2O. Let us keep going. Let us keep going. Let us go to molecular formula now. Molecular formula. I can clean the board. Remember, if you didn't get it, rewind and watch again. Molecular formula. Class, before I go to molecular formula, something is telling me to tell you this, and I'm thinking you might not know it. Class, some questions they'll give you on empirical formula whereby when you finish dividing, you end up having like 1 and 1.5. After you divide, you're going to have 1 and 1.5 like this. Let us say you divide it, follow the normal process. You now have C is 1 and H is 1.5. And normally the rule says that it's divided by the smallest number, right? So if you keep dividing by 1 divided by 1, you keep having the same thing. 1 divided by 1 is 1, and 1.5 divided by 1 is 1.5. Class, if you get to a stage like this in your empirical formula solving, where you have a whole number and a decimal, and when you keep dividing, and the whole number is 1, and you have a decimal like 1.5 or 1 point anything, and you keep dividing, you keep having the same thing, class, it's time to multiply. Class, your empirical formula cannot exist in decimals. And if you keep dividing by 1, nothing will happen. Let me tell you what you will do here. If I'm suspecting them, I want to bring a question like this. Class, what you will do here, listen carefully, because I will set something like this in a mock exam. Remember that after the 4 weeks class, we're going to have a serious mock exam. That exam will be harder than your main exam. Everything we said we'll do, we're going to do. I've already sent some people their past questions. Those that finished paying, by now you have your Jamb Master Pass question for both science, art, and commercial students. You have a Jamb Master Pass question. The mock exam I said we're going to do, we'll do it. After this 4 weeks challenge, we're going to do what? The mock exam. We're going to do it. So listen carefully. Let us say you divided. After doing the empirical formula, you now have 1 and 1.5. And if you keep dividing by 1, you keep having 1 and 1.5. Divided by, because 1 is the smallest number. 1 is the smallest number. Class, you now have to multiply. Class, you look for the smallest number, you multiply both of them. That will give you the closest whole number. Class, multiply this guy both sides by 2. 1 times 2 is 2. 1.5 times 2 is 3. Class, anything we multiply by 2 and we do not have a whole number, we increase the number to 3. Multiply both sides by 3. Keep increasing the number until you get to the what? To a whole number. Please take note. So the final answer will now be C2H3. This is when you solve empirical formula, and after dividing by the smallest, you end up having 1 and 1.5. This is what you are going to do. If you don't understand, rewind the video and watch again. Let us go to molecular formula. Let us go to molecular formula. Class, you can see how we are covering. Let us go to molecular formula. Molecular formula shows the actual number of atoms. Molecular formula shows the actual number of atoms of each element in a compound. Molecular formula shows the actual number of atoms of each element in a compound. Class, let's call molecular formula MF. Class, the formula for molecular formula MF is empirical formula EF multiplied by N, where N represents the number of atoms, the number of what atoms, and N has a formula. How do you get N? N is the molecular mass of the compound divided by the empirical mass. Molecular mass divided by the empirical mass. Molecular mass divided by the empirical mass. That's how you get N. Because without getting N, you cannot get a molecular formula. The molecular formula is a multiple of the empirical formula. So class, anytime someone has to find molecular formula, you must first get empirical formula. So you see why I put the topic before each other. And you cannot get empirical formula if you don't get percentage composition. Right? And you cannot get percentage composition if you don't know the relative RMM and RAM we did. Relative atomic mass, relative molecular mass. I carefully, intentionally selected these topics. Like tomorrow, I'll be teaching balancing of chemical equation. If you struggle with how to balance chemical equation, if you miss tomorrow's class, I will teach you a shortcut approach of how to balance equation. You will never have issue with balancing of equation again in this life. All your issues with balancing of equation and stoichiometry ends tomorrow. So I chose topics day by day. I know what I'm doing for you for your Jamb. Jamb only sets 40 questions. Do you understand? So Jamb cannot bring questions from everywhere. Only 40 questions will come out. Only 40 questions will come out. So class, molecular formula is empirical formula times n, and who is n? N means number of atoms. How do we get number of atoms? Molecular mass divided by empirical mass. Class, they usually give you the molecular mass. They will give you the molecular mass. But how do we get the empirical mass? Class, the empirical mass is gotten from the empirical formula. Class, let's look at that former question we did. We got empirical formula was what? CH2O, right? So how do you get the empirical formula mass? How do you get the empirical mass? You're going to add up the mass of each atom in the empirical formula. Carbon is 12. Hydrogen is 1. 1 times 2 is 2. Oxygen is 16. 12 plus 2 is 14. 14 plus 16 is what? 30. So the empirical mass is 30 grams. Class, molecular mass is not you that will solve for it. They will give you in the question. They will give you the molecular mass in the question. They will give you the molecular mass in the question. But the empirical mass is gotten by adding up, getting the empirical formula, adding up the masses of each atom inside the empirical formula. Adding up the atoms, the mass of each atom in the empirical formula will give you the empirical mass. Class, no matter how many times I explain, I will explain entire, no evidence until I give you a question. Let me give you a question. If I don't give you a question, I will explain entire. Class, very good. Let us take a continuation of the first question we gave you under empirical formula. Class, continue that question. So under that question, remember that the question started by saying, what was that question again? That we should find the empirical formula, right? Of what? Of a compound containing 40% carbon, right? And 6.7% hydrogen. They omitted oxygen, but we did oxygen and we got what? 53.3%. Remember, class. Class, continuation of that question. Given that, class, continuation of that question. Given that the molecular mass of the compound, given that the molecular mass of the compound is 60 grams, find the molecular formula. Given that the molecular mass of the compound is 60 grams per mole, actually it should be gram per mole. Given that the molecular mass of the compound is 60 grams per mole, find the molecular formula. I hope we are still together. I hope we are still together. I will not leave to the end. I will not leave to the end. I will not leave to the end. I will not live to the end. Someone says, sir, I thought N is mass over molar mass. Class, this N here. Someone says, sir, I thought N is mass over molar mass. This N is not number of moles. Oh. That N that is mass over molar mass is number of moles. Class, this N is not number of moles, it's number of atoms. It's not anywhere you see N, you call it number of moles. Class, allow N breathe sometimes. N, it's not all N that is number of moles. This particular N is number of atoms. This particular N is number of atoms. Class, so we have to find the molecular formula. If the molecular mass is 60. How do you get molecular formula? Empirical formula times N. Thank God we've gotten empirical formula as CH2O, remember. We have gotten empirical formula as CH2O. Now to get molecular formula, you need empirical formula times N. We have empirical formula is CH2O. But we don't know N. Let's go and find N. Who is N? How do you get N? N is molecular mass divided by empirical mass. What is the molecular mass? 60 grams per mole. I told you they will give you the molecular mass. They always give the molecular mass 60 grams. But the empirical mass you have to solve for it. But thank God we have solved for it. How do you get the empirical formula mass? Take the empirical formula and add up the masses of each atom. Carbon 12, hydrogen is 1 times 2, 2, oxygen 16, giving you 30. So N is molecular mass all over empirical mass, which is 30. 60 divided by 30 is what? 2. 60 divided by 30 is 2. So N is what? 2. Now that we know that N is 2, molecular formula is empirical formula times N. Who is empirical formula? Ca2. Who is N? 2. Meaning that to get molecular formula, multiply everybody here by 2. 2 times C is C2. 2 times H2 is H4. Because H is already 2, so 2 times 2 is 4. O2. Class, this is the molecular formula. C2H4O2. Molecular formula is C2H4O2. Molecular formula is C2H4O2. Class, one more topic to go. Congratulations, you tried. One more topic to go. One more topic to go. Isotopy. One more topic to go. Class, excellent. Well done. If you are still here, type I am still here, sir. If you are still in this class, type I am still here, sir. We have almost spent 100 minutes in this class. Class, this is smart work, not hard work. Those of you that started our Jamb class with us before we started this 30 days challenge, if you notice, sometimes we usually want to spend up to 4 hours, 500 minutes, 300 minutes. Class, that was hard work. Now we're doing smart work. You are behaving like the smart Jamb reader. This is a smart Jamb reader. We have not spent up to 100 minutes, but see what we have covered. We are using direction. We are reading with direction. And we are planning with direction. It's not by how long. It's by what are you achieving. What are you achieving? In case you are very good in chemistry, I know day one may look very simple to you. If you are very good in chemistry normally, day one must look very simple to you, right? But watch out for day 2, day 3. When we start entering tougher topics, electrolysis, organic chemistry, alcohols, aldehydes and ketones, carboxylic acids. Watch out for those times. Watch out for when we enter acids, polyprotic acid. What is a polyprotic acid? When we enter Lewis theory, Bronsted-Lewis theory, amphoteric substances, we are getting to tougher topics. Don't worry. We are getting to tougher topics, but we must start from the foundation. We must start from the foundation. So if you are very good in chemistry, I'm sure today must have looked very simple. If you look as if you did not gain much, don't worry. Your day is coming. Only about 2 or 3 questions may come out from here. Day 2 has more questions that will come out. So don't worry, we'll get to tougher questions. Day 1 is usually very simple because it's the beginning, the foundation. Yes. Isotopy. If you are still here, type I am still here. If you are still here, type I am still here. I am still here, sir. Type I am still here, sir. If you are still here, type I am still here, sir. Isotopy, and we'll go and rest. Well done, class. Well done, class. You have tried. Isotopy. Isotopy. Let us go, class. Let us go. Let us go. Let us go. Yes, everybody's typing. I'm still here. Everybody, Raphael, well done. Omawumi, well done. Well done. Everybody's typing. I'm still here. Ifechuku, well done. Kende, everybody's saying I'm still here. Well done, class. 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 Isotopy is a phenomenon. Isotopy is a phenomenon that occurs in atoms of elements. It is a phenomenon that occurs in atoms of elements, showing similar atomic number but different atomic mass. But different atomic masses. Isotopy is a phenomenon that occurs in atoms of elements, showing similar atomic number but different atomic masses. The atomic number is the same, but atomic mass is different. Class, in the 2 videos we did earlier, remember I told you we have done 2 videos earlier before we started this day 1. In those 2 videos, I've taught our students about atomic number and atomic mass in that video. After this class, I will drop the link to the video on the group again. Make sure you watch those 2 videos. Because I've told them that if you have an element X, class, there's a number you have above the element and there's a number you have below. This number you have above is the atomic mass. And this number you have below is called the atomic number. In those two videos, I broke down the foundation of chemistry for our students. If you're here, you're struggling with chemistry, go and watch those two videos. I started chemistry from the foundation. I explained protons, neutrons, and electrons. I explained why elements want to become charged. Why every element wants to be like the noble gases. I explained the electronic configuration, K element shell. I taught it like I said, very simple. There was one of the videos, I spent almost 4 hours in that video. Yes, I spent almost 4 hours in that video. That's the foundation. I will send the link again. So class, if you have an element, the number on top is atomic mass, the number below is the atomic number. But class, what happens in isotopy is this. For example, chlorine, the same atom of an element, the atomic number 17, 17, they are the same. When you get the atomic mass, this guy is 35, exists as 35, this guy exists as 37. So imagine the same elements having the same atomic number but different atomic masses. Class, when this occurs, we say isotopy has taken place. So isotopy is a phenomenon in elements having the same atomic number but different atomic masses. So class, elements that exhibit isotopy are called isotopes. Elements that exhibit isotopy are called what? Isotopes. Class, there's a formula. There's a calculation involving isotopy. Class, because elements that exhibit isotopy, they can cause confusion in the chemistry world. These elements cause confusion in the chemistry world. Why? Because if someone asks you what is the mass of chlorine, some persons will say 35 and some persons were saying 37. It caused a lot of conundrum in the chemistry world. We started wondering, should we go with 35 or should we go with 37? Not until a scientist came up with a formula that helped us to calculate the average mass. Okay, let us be calling chlorine this. Let's come up with a formula that helps us to get the average atomic weight of elements that exhibit isotopy. Class, because if one chlorine is called 35 and another is called 37, we must then find the average. What can we say? What's the average? Let us settle for one. There's a formula that helps us to get the average atomic weight of chlorine. And class, to get the average atomic weight of chlorine, there are two things that are needed. One is what we call the atomic mass units. Atomic mass units, AMU. And there's what we call the relative abundance. We call this RA. Class, the atomic mass units of each of the isotopes. For example, the atomic mass unit of chlorine is usually very close to this 35. Usually you see something like 34.9999 or 9989. And the atomic mass unit, AMU, the unit is AM. And the atomic mass unit for chlorine 37, you see 36.99789. If you approximate 36.997, you still have 37. AMU. The atomic mass unit, as the name implies, is the atomic mass of each of the isotopes. Remember that they have different atomic mass. Class, what is the relative abundance of the isotope? Relative abundance is how much of the isotope is present in the atmosphere. How much of chlorine is present, how much of chlorine 35 is present, how much of chlorine 37 is present. How much of chlorine 35 is present, how much of chlorine 37 is present, we need to know. These two things are what we use to calculate the average atomic weight. What is the average atomic weight? It is the average mass we'll be calling chlorine, because there's confusion. Should we call chlorine 35 or should we call chlorine 37? The formula I'm about to give you now was a simplified formula that helps us to determine the average mass of elements that exhibit isotopy. And that formula takes into consideration two key parameters. One is the atomic mass unit of each of the isotopes, AMU. Two is the relative abundance of each of the isotopes. How much of the isotope is present in the atmosphere. Class, are we still following? If you are following, type, I am following you, sir. Sir, I am not sleeping. Sir, sleep want to catch me, but I am not going anywhere. And we are almost done, sir, so I must stay to the end. Sir, this is the last topic now. Let me just stay to the end. Let me just stay to the end. Let us go, class. It's time to give you the formula now. It's time to give you the what? Formula. Because I give you the formula, then we'll take questions. Class, it is very likely that question will come out in isotopy in your chemistry. It is too popular to ignore. Class, it is not possible that all these topics we taught today, one question will not come out in Jamb. It is not possible. There is no year that Jamb has set question. And they did not bring question on everything we just did. It's not possible. It is not possible. Class, don't forget what we're trying to achieve now is the average atomic weight. The average atomic weight. The average atomic weight is, let's call this first isotope A, and let's call the second isotope B. Average atomic weight. Now everybody knows what average means, right? Because we have 35 and we have 37, we need to find an average mass we call it chlorine. That's the average atomic weight. The average atomic weight is the average weight or the average mass that we're going to give it to chlorine. Because 35 and 37 is giving us confusion. We cannot have two. Let us have one average. To calculate the average, you're going to consider the atomic mass units of each of them. So AMU of isotope A multiplied by relative abundance of isotope A who is isotope A? Chlorine 35, right? Now, now say plus AMU. Who is AMU? Atomic mass unit, right? AMU is atomic mass. AMU of isotope B multiplied by relative abundance of isotope B. So this is how you are going to have the average atomic weight. Please write this formula down. Please write this formula down. Please write this formula down. Class, we are almost at 100 minutes. We are almost at 100 minutes. This is good. We are almost at 100 minutes. Everybody saying, I'm following you, sir. Well done, class. I like this set. I like this class. Everybody saying, we are following you, sir. Everybody saying, we are following you, sir. At least those that were doubting. There's one girl that I replied very late. After she registered with us, it took me like 2 days before I replied her because my phone was hanging. Too many students are messaging me. Too many students want to pass Jamb. They're messaging me. People are referring me from different places. So my phone hanged and I did not reply her for like 2 days. So she thought they have scammed her. When I finally replied her, she was shocked. And I added that to her group. Say, so you replied. I said, how would I reply? You cannot pay me and I already, it's not possible. I have a reputation to protect. So some of you at least you can see the class now. This is live. You can see my face. This is the Jamb master. So all your doubts. Some of you maybe we finish class by 8. I came by 8:30. Some of you still be thinking, hey, has he run away? Who's running away? Don't forget that we have art students, we have commercial students. Before I come and teach science, I have to organize the art and commercial so they will not feel left behind. If you two you are art students, you will not be happy if I just let them and come and teach you only. So I just go and organize the class, organize teacher, tell the teachers what to do. They have their own teachers. They are working under me. I say, okay, teach. Then I come back to my science students and teach. So don't think that we're not taking you serious. We're taking you very serious. I don't joke with my classes. So I don't joke with my classes. Look at my board. This thing is a serious work I'm doing. This board is in my house. I'm in my house now. I cannot be anywhere by this 10:30. I cannot be anywhere by 10:30 at my house. So where would I run to? I have a board in my house. So I'm out to teach you. So never think that if maybe for one reason or the other I don't come live at that time we chose. Don't think that I'm not serious. Maybe something happened. Maybe someone is calling in. Look at the live we did earlier. Someone was calling me on the phone and they spoiled our life. We have to fix another life. So I don't joke with my classes. I don't joke with my classes. Yes. I think we should be at 100 minutes now. Let's take question. Let us take question. Almost 100 minutes. This is good. Let us take questions. If you are ready, say, sir, we are ready. If you are ready for questions, say, sir, we are ready. If you are ready for questions, say, sir, we are ready. We are ready for questions. If you are ready for questions, say, sir, we are ready. If you are ready for questions, say, sir, we are ready. We are ready. If you are ready for questions, say, sir, we are ready. Sir, we dey here. We dey here. Let me look for a very good question for you. Let me look for a very good question for you. Make sure you don't leave. Oh, you are almost at the end. This is not where you should be living. Imagine, almost close to your breakthrough. You now go. Make sure you don't leave. Let me look for a very good question for you. Make sure you don't leave. Make sure you don't leave. Make sure you don't leave. Let's look for a very tough. I'm looking for a tough question. That's why I'm taking time. I'm looking for a tough question for you. Let's end it with a very wicked question. Yeah, let us go, class. An element with relative atomic mass 16.2. An element with relative atomic mass 16.2. Write down. An element with relative atomic mass 16.2. An element with relative atomic mass 16.2. An element with relative atomic mass 16.2 contains two isotopes. Contains two isotopes X16-8. Contains two isotopes X16-8 with relative abundance of 90% and MX8 with relative abundance of 10%. Find M. Find M. Who got the question? Should I come again? Let me come again. An element with relative atomic mass 16.2. An element with relative atomic mass 16.2 contains two isotopes. What's the first isotope? X16-8 with relative abundance. Ra means relative abundance, right? With relative abundance of 90% and MX8 with relative abundance of 10%. Find M. They ask us to find M. Class, let us take another question. So we are done with anything isotopy. So I will know we are done with everything what? Isotopy. Take this question down. If 100 atoms of element X, if 100 atoms, another question. If 100 atoms of element X contains 70 atoms of X9 and 30 atoms of X11, calculate the relative atomic mass of X. Calculate the relative atomic mass of X. Let's look at these two questions. Have you gotten the question, class, so we can solve? Once we finish these two questions, class, congratulations, we have achieved our target for today. And the confidence that we gain today will help us to even push further tomorrow. Are we together? Are we together? The confidence that we gain today will help us to push further tomorrow. The confidence that we gain today. If you are still with me, you can hear me. Say, we can hear you, sir. Can I start solving so we can close for the day? Can I start solving? Let me know in the comment. Let me know who is still with me. Who is still with me? Who is still with me? Let me know so I can start solving. If you are with me, say we are with you, sir. Yes, Raphael Ajibade said we can hear you, sir. That is the energy. That's the spirit. We can hear you, sir. That is the energy. I like this. That is the energy. We can hear you, sir. We can hear you, sir. This is good. Yes, that is the energy we need. We are with you, sir. Good. Let us solve and close for the night. Let us solve and close for the night. Class, they gave us in the question, where is that question again? An element with relative atomic mass of 16.2. Class, they told us the element has relative atomic mass, class. Relative atomic mass. This was the first thing we did today, class. This was the first thing we did today. Check the topics I wrote down in the beginning of the video. Relative atomic mass, relative molecular mass. So everything is linking. Now the first topic is linking us to the last topic, isotopic. Are you together, class? Everything was chosen carefully. I know what I'm doing. I know what Jamb. I know where Jamb goes. I know where Jamb is going. All the topics I will teach you, you see how they will be flowing for your Jamb exam. After we finish the 7 days, take any year of Jamb pass question. At least you get at least 30 over 40. At least. If you finish this 7 days challenge, you don't miss one day. Don't miss one day. See what will happen. Class, they say this element X, which relative atomic mass 16.2, has two isotopes. Class, the good thing about this question is that the popular thing they usually ask in isotopy, they've already given us in this question. Class, this element has two isotopes, X16.8 and XM8. Class, normally they were giving us this 16 and giving us something like maybe 18 here. And then ask us to find the average, right? But this time around, they are giving us the average at 16.2. Class, relative atomic mass also means average atomic weight. Relative atomic mass also means what? Average atomic weight. I intentionally did not claim this formula. Relative atomic mass also means what? Average atomic weight. So class, they're giving us this guy that we're usually looking for, 16.2. They're giving us 16.2. Now, isotope A means the first isotope, which is 16.8. Class, the AMU of 16.8 is 16. You can see 16. So this is 16. Multiplied by the relative abundance of A is 90%. Multiplied by 90 over 100. Plus, right? AMU of isotope B is M. We don't know. M, we don't know. Multiplied by what is abundance? 10%. 10% means 10 over 100. Class, 90% means 90 over 100. 10% means 10 over 100. So what do we now have, class? What we have here is that 16.2 equals to 16 times 90 over 100, right, plus M times 10 over 100. Class, they say we should find M. Remember, find M. We need our calculator now. 16.2 equals to 16 times 90 over 100. We need our calculator. Where is our calculator? Yes, our calculator is here. Sixteen times 90 equals 1440. Divided by 100. Plus M times 10 is 10M all over 100. Class, 16.2 will now be equal to 1440 divided by 100 will give you 14.40 plus 10M divided by 100. 0 cancels 0. So 1 over 10 is 0.1M. 0.1M. Class, let's bring 0.1M to this side and bring 16.2 to this side. When 0.1 m comes to this side, it becomes minus 0.1 m. What makes m shorter from that? We already have 14.40 here. When 16.2 comes to this side, it becomes minus 16.2. So we're going to ask ourselves, what is 14.40 minus 16.2? This is now minus 0.1 m equals to minus 1.8. Class, minus can cancel minus. Then divide both sides by 0.1. 0.1 cancels 0.1. So that m equals to 1.8 divided by 0.1. M equals to 1.8 divided by 0. And that will give us what? 18. So class, the atomic mass unit of the second isotope is 18. M is 18. Who got it before I got it? Sir, I got it before you got it. Sir, I got it before. Let me know. If you didn't still get it, no problem, no pressure, no pressure. You will still get it in your own time, right? You will still get it in your own time. You will still get it in your own time. It's time to solve the second question and we'll call it a day. We have tried for today. Well done, class. Well done, class. Well done, everybody. Well done, everybody. Let us solve the last question for the day. Let us solve the last question for the day. Let us solve the last question for the day. Someone said finally. Someone said finally. It's like some new students said, no, that we used to do 4 hours class. Ask your friends that have been here. We used to do 4 hours class sometimes. 4. Ask them. We have done 300 minutes, 200 minutes before. Ask your friends. So someone said finally. Okay. I can claim you can rewind and watch again. Don't forget. Don't forget everything we have done today. Tomorrow morning, when you are woken up, rewatch again. Rewatch again. Take more questions. Take more. Look for jump pass. I already gave you jump pass. Take more questions. Look for questions on isotopy. Your job now, before tomorrow's night session, watch the 2 videos. If you've missed the 2 videos that we did before, watch it. I will send the link on the group. Also, if you've watched that one already, watch this video again. Take more questions on the topic we did. Look for your jump pass. Take more questions. Look for any topic in this question. Take more. Take more questions on isotopy. Yes. If 100 atoms of element X, if 100 atoms of element X contain 70 atoms of X9 and 30 atoms of X11. Class, what? 30 plus 70 is 100. This 100 atoms, you're not going to use to do anything. This is just to confuse you. What this just means that if 100 atoms means 100% of element X, 100 atoms means 100% of element X, contains 70% of X9. So relative abundance of X9 class is 70%. Because 70 over 100 means 70%. And 30 atoms of X11. Relative abundance of X11 is 30%. So this is another way of giving you relative abundance. Be careful. 70 atoms, 70 of 100 is 70%. 30 of 100 is 30%. Calculate the relative atomic mass. So this we're looking for this guy now, relative atomic mass. This is what we're looking for. So we don't know this guy. We're looking for this guy. Relative atomic mass equals to AMU of the, what is the first isotope? 9 times relative abundance of first isotope is 70%. 9 times 70 all over 100 plus AMU of second isotope 11 times relative abundance of second isotope 30 all over. We'll then do the maths. 9 times 70 looks like 630 all over 100 plus 11 times 30 looks like 330. Six 30 over 100 is 6.3. 330 over 100 is 3.3. 6.3 plus 3.3 looks like 9.6. I'm using my head, I'm not using calculator, but I think I'm right. So class, our average mass is 9.6 grams. Who got this before I got it? Who got this before I got it? Guys, congratulations. We achieved our target for today. Where is that person that said on the group, sir, you sure we can cover? I was just laughing. This is smart work, not hard work. Class, when you have a direction, you have a purpose, and you have what you want, a goal for every day, you will cover. This is not the first time we are doing this. I was just laughing. It's not even up to 2 hours. Class, check. It's 111 minutes, 100. It's not up to 100. Is it up to 120 minutes yet? And I've covered all these topics. It's not up to 120 minutes. We can do it. Class, excellent. 115 minutes. 115 minutes. So you see how the Jamb challenge goes? You have seen the idea now, right? So tomorrow when we come, we already have topics we are covering for tomorrow. You shouldn't have faith that definitely this guy, okay, they will cover. Now, don't be that doubting before. I'm sure you should believe now. Don't worry, I've seen. Okay, so this is how it is. You can see how clear my board is. You are seeing me live. This is not WhatsApp notes. You are seeing me teaching live. So I hope all the doubts now will be done and dusted. Tomorrow by 8:30 within that time. So I may not start exactly 8 because you understand now, right? You have to go and organize the art and commercial. Because one day they used to feel that you're not teaching us, you're only teaching the science students. But I used to like give them some more attention before I now come to you. So don't panic, say sir, it's 8 p.m. Some people were typing me, sir, it's 8 p.m. Sir, where are you? Like, no, I'm not running away. Like I said, this is my board and this is my house. This is my board and this is my house. So it's my job, it's my work. I teach every day. I teach 100 level students. In my shop, after this class is over, and I still have class with my 100 level students online. I teach them online sometimes because their 100 level schedule is so tight. Sometimes I teach them in the night online. So I teach. It's my work. I teach. So don't worry yourself. So this is the class. Congratulations if you stayed to the end. If you enjoyed today's class, let me know in the comment section. Sir, I enjoyed it. If you learned something today and you like the class, let me know in the comment section before we go. If you like the class, you enjoyed it today, let me know. If you have not subscribed to our channel, hit the subscribe button. If you have not subscribed to our channel, before you go, hit the subscribe button. Someone said I understood everything very well. Even though you were fast, thank you. Remember that even if I was fast, you can rewind and watch again, right? Yes, someone said today was extremely excited. Thank you, I enjoyed the class. Yes. Those of you that were complaining of English, I was laughing. Only our English class holds on Telegram. All the other subjects hold live. You see us teaching live. It's only the English class that holds on Telegram. So some of you have already used our English class to judge us. Like some guys, they are not in this class and they thought they have already given up. As they saw the English, they just gave up the R. So this is how they are. So they have scammed me. They don't have patience. They don't have small patience. Because they didn't join the and they paid. They just left. Yeah, I'm angry. No, who scammed you? How? Even the English class held every day. The English class, even if it was on Telegram, it was holding every day back to back. The woman was teaching and she was trying her best. Some of you see the effort we are putting in to help you. Are we together? So tomorrow, I like the fact that everybody said they enjoyed the class. I like the fact that you said you enjoyed the class. I like the fact that you said you enjoyed the class. Yes. Thank you, thank you, thank you. So tomorrow, 8 p.m., 8:30, I'll be back for you. Yes. 8 p.m., 8:30. Everybody said I understand. Everybody said I understand. You see? Everybody said I understand. I thought if I teach you, you will pass. You must pass your Jamb. You can't fail Jamb with me. It's not possible. Everybody said I understand. Good night, everybody. See you tomorrow, 8 p.m., 8:30. Yes, Raphael said tomorrow we'll move on. Yes. Tomorrow we move. Someone said I enjoyed today's class. Yes. Abiola Banjo said I enjoyed today's class. All thanks to God. You're the best, sir. Thank you. Thank you, everybody, for the comments. Thank you for the good comments. Thank you for the good comments. Thank you. Thank you. Thank you. Thank you. As I've told you, we cannot fail you. We cannot fail you. We cannot fail you. It's not possible. I'm the Jamb master. We cannot fail you. Good night. Good night. Good night. Good night. Let's save our data for tomorrow. Let's save our data for tomorrow. Good night. Good night. If you missed the live classes of those 2 videos, I'll post on the group now. I'll post on the group now. Take care, everybody. Take care, everybody. Have a good night rest. See you tomorrow.